This is a video on composition of functions where, given two functions, we will need to simplify the equation of the composite function and find the domain of the composite function. The first composite function we need to find is f circle g, which is f of g of x. F of g of x is f when we substitute in the place of x the expression g of x, which is 7 over x. So I'm going to do substitution inside f. The first substitution is for the x in the numerator to be 7 over x, and the second substitution is for the x in the denominator to be 7 over x minus 4. This is a complex fraction. To simplify complex fractions, I multiply numerator and denominator by the least common denominator, which is x in this case. So the equation of f of g of x is 7 in the numerator, and in the denominator 7 minus 4x. So that's the equation of f of g of x. Now, to find the domain of f circle g, we need to check two things. The first thing we have to check is that g that got substituted is defined. That means 7 over x is an expression that is defined, and expressions with fractions, they must have non-zero denominators. So our first condition is that x must be not equal to 0. The next condition is that f circle g is defined. That is the fraction 7 over 7 minus 4x. We need that to be defined, and to do that we must solve 7 minus 4x different from 0. So I'm going to go ahead and solve 7 minus 4x equal to 0. I will subtract 7, negative 4x equals negative 7, and I will divide by negative 4, and x is equal to 7/4. And if I want it to be different from 0, I'm going to end up having x different from 7/4. So I cannot have these values in the domain. So if I want to write it in interval notation, my domain will be from negative infinity to 0, open because it can equal 0, union from 0 to 7/4, open because it cannot equal to 7/4, union from 7/4 to infinity. That's one way I could write it. Another way would be with set builder's notation. X is such that x is different from 0, comma 7/4. So any one of these two notations is the same for the domain of the composition f circle g. Now I'm going to do the backwards composition, so I'm going to compose g circle f. I will do that by substituting inside g the expression for f of x, which is x over x minus 4. That would be 7 over x minus 4. To simplify this complex fraction, I'm going to multiply numerator and denominator by the least common denominator, which is x minus 4. The expression will be 7x minus 28 over x. For this function to be defined, first the function we substituted, f of x, must be defined. This means the expression x over x minus 4 must be defined. It has a denominator, which means x minus 4 must be not equal to 0, which means x must be not equal to 4. And the composite function g circle f must be defined, which basically means our final answer must be defined. And this also has a denominator, which is x, and x must be not equal to 0. So again, if I wanted to write that in interval notation, my answer for the domain of G circle F will be negative infinity to 0, open, union, 0 to 4, open, union, 4 to infinity. If I wanted to write this in set builder's notation, I would have written that the domain is x such that x is different from 0, 4.